haven't subscribed yet, hit the subscribe button and the bell icon to get instantly notified from the updates of Being Civil, a complete civil engineering tutorial channel. Happy learning!
Welcome to Being Civil. This is another example of unit load method. In this method, we will determine the slope and deflection of a cantilever beam subjected to a point load at the tip. Let's start. Those who have not seen the previous video, in the previous video I have uploaded a cantilever beam with uniformly distributed load. The link is in the description. Go and check it out. Coming to this problem, so according to unit load method, you have to apply a point load on the beam. Now have to calculate the bending moment at a distance, let x, from the tip. So what is the bending moment for the actual beam at a distance of x? It is px. The bending moment is like this. This coordinate is minus px, and for a beam with unit loading, this one is minus 1 into x equal to minus x. This ordinate is minus L. Here this ordinate is minus of PL. So we find out the moment of the actual beam and moment of the beam with virtual unit loading. So the deflection is integration 0 to L, the product of the two moment into dx by EI. As the sign is positive, the deflection is in the downward direction, that is in the direction of the applied load. Now have to calculate the slope at this point. So you have to apply a unit moment here. You have applied a unit moment here. So this bending moment diagram is nothing but a constant of value of minus 1. So the slope is integration 0 to L, the product of the two moment. The actual beam moment is minus px and the virtual one is minus 1. As you see, this is positive, so the slope also in the direction of the applied moment. So if you draw the deflected shape, so both are in the direction of the applied loads. Thanks for watching Being Civil. Stay subscribed. Give your comments in the comment section below. Thank you. Happy learning.